Hello, everyone. Miss Millender here, just talking about pressure today. So let's see what's going on. Okay, you've all felt it. You've all felt the pressure. But we're not talking about that kind of pressure. We're talking about air pressure. So what causes pressure in the first place? Well, it's all about collisions. The gas particles collide with each other. They collide with everything that's in their environment. They collide with the walls of the environment, and all that colliding causes pressure. So, come on, what's going on? There. So, in order to change pressure, you need to change the number of collisions. So, this is what we're talking about to make sure that you're looking at things in terms of consequences. What causes this and that causes what? And we'll go through that some more. So you have to change the number of collisions. Well, how do you do that? You can change the number of collisions, or you can change how forceful the collisions are. Either one of those will increase the pressure. Okay, so it's all about collisions. The collisions cause pressure. To change pressure, you need to change collisions. And what can you change about the collisions? You can change the number of them or how often they show up. Okay. So hopefully this won't be new to you because you've started doing the FET. And anyway, so you can change the speed of the particles, you can change the number of the particles, or you can change the space available to those particles. And knowing the definitions to all the words we were talking about, so you know speed of particles is temperature, yay. KE stands for kinetic energy. We didn't talk about this year, but it's important and I want to leave it in for maybe a subsequent year. Anyway, number of particles, what's that? Mass. And space available, volume. Okay, and now, so those are the three primary properties that you can change. Now, based on an earlier unit, when we were talking about the amount of sugar in your favorite drink, think back. What is it that you're changing when you adjust either the mass or the volume? Think back to that soda lab. Okay, mass and volume together in a formula. What do they represent? Density, yay. So sometimes it makes sense to talk about the change. Well, sometimes, especially if you're comparing a sample of gas and you're comparing it to the rest of the room, you're not going to say that the mass inside the flask, let's say, is the same as the mass of particles in the room, because obviously that's not true. However, you can compare them in terms of density. You can say the density inside the flask is the same as the density of the air inside the room. And if you recall, when we made that graph in the soda lab, we looked at what is the word I'm looking for? Oh, we looked at concentrations, right? So we were able to get the density and then predict the concentration based on that. So you can even use the concentration. You could say the concentration of the air particles in the flask is the same as in the room. You're going to change one of these specifically, but in doing that, you would change one of these, and you can use these terms interchangeably. Apparently, concentration is used more in the chemistry. So there you go. Okay, so we have our setup as before. So again, I'm assuming this all will make logic sense to you if you've done some of the FET. So if I increase the speed of the particles, what is that going to do to the collisions? The collisions are going to increase and they're going to be more forceful because the things are moving faster. So if the number of collisions increases, and they're more forceful, what are you doing to the pressure? You get more pressure. So pressure increases. Oh, I should have written it that way. All right. So in your notes, just write pressure increases instead of more pressure. Then if you decrease the temperature, what's going to happen to the collisions? The collisions are going to decrease and they're going to be less forceful. So you're going to do what to the pressure? You're going to result in less pressure. But again, I want you to write decrease in pressure. Sorry about that. Okay, so let's go on to mass. If I increase the mass, what's that going to do to collisions? It's going to increase them. Unless the temperature changes, the force of their collisions is not going to be any different. But so we'll just say the collisions increase. So if collisions increase, what does that do to the pressure? Increases the pressure. And if I take some of that mass out of the situation, like with a vacuum pump or something, the number of collisions are going to decrease. And what does that do to the pressure? It decreases the pressure. So let's predict the ones that you're going to do next. The space available is volume, right? So if I increase the volume, what's that going to do to the collisions? Think about this. So if I increase the volume, I'm actually going to decrease the collisions. So this is different than mass and temperature. So if I increase the volume, that means there's more space for the gas particles to bounce around, which means they're not going to collide as often as they did before. So what's that going to do to the pressure? It's going to create less pressure. The pressure is going to decrease. So that's what I'm asking you to write here, is decrease. The pressure decreases. All right, so now what happens if I decrease the volume? If I make the volume smaller, I squeeze things more together. What's going to happen to the collisions? Hopefully you got it. The collisions are going to increase because there's now less space for all those gas particles to be bouncing around. So they're going to hit each other more often. And what's that going to do? That's going to increase the pressure. So it looks like a lot on the page, but I think it makes a lot of sense. And so maybe you have to get through it a couple times. So with temperature and mass, there's a direct relationship, or they're directly proportional. You increase the temperature, you increase the collisions, you increase the pressure. Same with the number of particles. You increase the mass, you increase the collisions, which means you increase the pressure. But with volume, it's an inverse relationship. So when you increase the volume, you're actually decreasing the collisions and decreasing the pressure. And if you decrease the volume, you're increasing the collisions and getting more pressure, increasing pressure. Okay, so temperature and mass and collisions and pressure are directly proportional. Collisions and volume are inversely proportional. Okay, so here's the bottom line. Pressure can only push. Hopefully you got that out of Julius. This, oh, murders me as Macbeth doth murder sleep. Pressure can only push, the push of the air. He said that 1,000 times in the video. Okay, you can't see air itself, right? But you can see the effects of the air on other things in the environment. So you know it's windy because you see the trees are moving around. You might know that there's a greater pressure in the balloon because you can see the balloon expanding. So we can't see the air, so we're using other things to show us what the air is doing and where the push is coming from. Okay, so I mentioned this in class. Suction is simply caused by an area of higher pressure pushing on an area of lower pressure. So even when you sip your drink through a straw, you're not sucking that liquid up into your mouth. What you're doing is you're creating an area of lower pressure in your body. So the outside pressure in the air pushes on your drink and pushes it up into the straw into your mouth, which is really weird to think about because that's not how you've ever thought of it before. But in fact, that's what happened. Pressure cannot pull. There is no such thing. So when Julius was doing that thing with the membrane going down into the funnel, there was nothing inside the funnel pulling on that membrane. Nothing. It was all about the push from the outside air. Okay. Suction cups, misnomer right there. Low pressure area cups or something. I don't know. All right. So if you have questions, bring them to class. And thanks very much for watching.